Example 2, finding and comparing conditional probabilities. A satellite TV provider surveys customers in 3 cities. The survey asks whether they would recommend the TV provider to a friend. The results are given as joint and relative frequencies are shown in the two-way table. So if you look at your table, we're dealing with percentages because these are joint and relative frequencies, which are like part B of our previous example. Part A. What is the probability that a randomly selected customer who is located in Glendale will recommend the provider? So first of all, we're not only dealing with a probability, but this is a conditional probability. And we're dealing with somebody who is, first of all, located in Glendale. Well, if they're located in Glendale, well, then I know I'm dealing with all of these people. So we're going to take our 0.29 plus our 0.05, which is 0.34. So I know that my denominator in this probability is we're only working with the Glendale, so 0.34. Now, of those, what's the probability that they're going to recommend the provider? Meaning, what's the probability they're going to say yes? Well, that's 0.29. If we figure this out, that's roughly 0.8529. So we're looking at roughly 85.3%. Part B. What is the probability that a randomly selected customer who will not recommend the provider is located in Long Beach? So in this case, we're working with who will not recommend the provider. Well, if they're not recommending the provider, that means that we're dealing with anybody who said no. So anybody who said no, if we add this up, we're looking at about 12% of participants are saying, no, I'm not recommending the provider. And I want to know, of that 12%, what's the probability that they're located in Long Beach? Well, that's about 4% of them. So we're going to have 0.04 divided by 0.12, which is roughly 33.3%. Part C. Determine whether recommending the provider to a friend and living in Long Beach are independent events. Now, we're working with are they independent events, but this is conditional probability. So really what we're trying to figure out here is the probability of living in Long Beach the same, and I'm going to put a question mark because we don't know right now, as the probability of living in Long Beach given that you're going to recommend the provider. So first of all, we need to find, okay, well, what's the probability that we're going to be living in Long Beach? So up here, this is our Long Beach. If we add these together, we have a 36% chance of living in Long Beach. Now, is this the same as the probability of living in Long Beach given that you've now said yes? Well, given that you've said yes to the provider is this row right here. So we've got 29%, 27%, 32%, which is going to get us a total of 88% of respondents are going to recommend the provider. Now, of those 88, 32% are living in Long Beach. So we already know that this one is 36%. If we take 32% divided by 88%, we're going to get roughly 36%. So yes, these two events are independent because when we find their probabilities based on our table, they are equivalent.